Hello everyone, I am Sunita from SNS College of Technology, Department of Mathematics. As the continuation of the lecture series in standard distributions or probability distributions, here in this lecture video we are going to see what is Poisson distribution. So in probability theory, we often come across situations where we need to find probability of occurrence of a particular number of events in a fixed interval. So in this in the cases like number of customers arriving at a station, number of accidents occurring on a road, number of calls received in a communication system. So in such situations, probability distributions like Poisson distribution provides an effective mathematical model to identify the solution. So here is the recall part. So before understanding Poisson distribution, let us recall the idea of discrete probability distribution. That is, event occur independently, event occur randomly, average rate of occurrence remains constant, and we count the number of occurrence within a fixed interval. So the random variable x represents the number of occurrences of an event. So the parameter lambda represents the average number of occurrences. Like that, we need to know what is mean, median, and mode. So here is the dt of Poisson distribution. So first is define defect rate, calculate probability, apply Poisson distribution, next find the probability of zero defect. So let us see the formula first. So the narration part. So p of x is equal to e power minus lambda, lambda power x into x factorial, where this p of x stands for probability of exactly occurrence of x events. Next, lambda is the average number of occurrences, x represents the number of events, e represents the exponential constant. So next is a problem explanation. So let us consider a problem discussed in this topic. So that is, on a booking counter, on the average 3.6 people come every 10 minutes on weekends. So what is the probability of getting 7 people in 10 minutes? So like this, we are going to see problems in this Poisson distribution. So in these we will be seeing average occurrence rate, required number of occurrences, and factorial value. By simplifying the expression, we obtain the required probability. So this problem process demonstrate how probability distribution or Poisson distribution helps solve real life problem count. So here the mu is equal to 3.6, x is equal to 7. So we know the formula p of x is equal to x as e power minus lambda, lambda power x by x factorial. And we know that lambda is equal to mu. So therefore we are substituting and simplifying, we are getting it as 0.0424. So here is one more example. Suppose that a rare disease has an incidence of 1 in 1000 person per year. So assuming that members of the population are affected independently, find the probability of k cases in a population of 10,000 for k is equal to 0, 1, 2, 3. So the expected value will be lambda equal to 0.001 into 10,000, which is equal to 10. So that means 10 new cases expected in the population per year. So next is the calculation when x is equal to 0, x is equal to 1 and x is equal to 2. So here is one more example, and this is the variance of Poisson random variable. So v of x is equal to e of x square minus e of x the whole square. Next, where x is equal to 2, that is e of x square is equal to summation x square lambda power x e power minus lambda by x factorial. So similarly, we have e of x square as lambda square plus lambda and variance as lambda. So for this Poisson distribution, mean and variance both are lambda. So here is an assessment question. in which a key property of the Poisson distribution in the relationship between its mean and variance. So we know that mean and variance, they are both are same. Next, if a hospital emergency room receives an average of 5 patients per hour for a certain condition, what is the probability of receiving exactly 0 patient for that condition in given hour? So this can be solved using the given formula. Here are the reference links and thank you.